In addition to integrated energy management, energy efficiency under the green building, we cover also water management, waste management, carbon footprint reduction, overall greening impact, and at the end of the day, overall quality of life for the people. And that's more important, be it in terms of all the health and well-being issues become an important one. Energy is one of the major concern area for all, and more than 35% of all the energy consumption is taken by the building industry of all the asset classes. And therefore, whatever you can save in the building industry, and building industry is contributing very highly in the GDP of the country. Nearly around 11% of the GDP is coming from the building construction sector, and that's a very critical one. And any saving in the energy that you can do will go a long way. And therefore, there are a large number of methodologies which are done on that. We are at present consuming about 3.71 lakh megawatt of power from the all over, which is likely to increase at 5 lakh megawatt of power in the next around 5 years time period, with the demographic growth, population increase, additional housing, additional buildings, all that is the industry, everything to come up, hospitals, hotels, all joining in a big way. So we got to see how best we'll be able to contribute in the sector. India is not using much of per capita energy. It's only based on, if the US is taking around 12,900 units per year, kilowatt hour per person per year. India is consuming only 1,181 kilowatt hour per person per year. Just less than even 1/10 of that. The global average is about 2,674. And it's very necessary that, I'm not saying that we got to be like what US is, but we can at least be closer to per capita consumption of energy. Is also an index of development index that we have. And therefore, we are to see how best we can conserve energy, use it efficiently, use it effectively, use it economically. Very important. Each word has a different meaning. And most importantly, as a result of the effort of the green building movement, we have been able to contribute in a very big way over the last 20 years time period. In terms of the building footprint itself, we have crossed in 20 years time period 7.61 billion square feet. That's about 761 crore square feet of green building of all asset class of building, commercial, residential, hotel, hospital, schools, colleges, factories, retail, whatever, all asset class of building, as well as the built environment, which will cover the campuses, townships, as well as cities in a large way. And I'm very happy that over the last 20 years time period, maybe in the beginning of the year, if we would have consumed about 10 megawatt per million square feet of building, now it's come down to roughly about 6.5 megawatt per million square feet of building. That's a very big one, clearly showing a 35%. In fact, energy efficiency can be even as high as around 35 to 40% there. And the best way to do that particular thing is a combination of effort by all the players working in that. The architect will play an important role because he conceptualizes the three-dimensional space of the building, or length, area, width, height, and the volume of the whole building, and the envelope of the whole building there. And therefore, the architect and the civil engineer combination in the initial area will contribute to the passive design of the building, which will cover the orientation of the building with respect to where you are located, and with respect to your solar park movement that you have. Fortunately, India has got 95% of the clear design sky, as against UK, Europe, Canada, and most part of America. They've got the standard overcast sky. So they are not able to utilize the solar energy to the degree that's required. So we should be able to utilize Surya Bhagavan in the best possible way for utilizing for energy requirement design. Therefore, the whole design of the orientation based on the sun path of the particular one. How do you orient your building with respect to the sun coming from the eastern side towards the western side, and the southern side, we are the northern hemisphere. So southern side is the one which gets the warming up in a large way. How do you design those particular features for tracking those particular area? Where do you put the windows so you don't have the maximum heat coming on the area where the solar impact will be much more there? And equally important to that particular area are also those walling and related area, including glass as a facade material, as well as walling and other material, whatever material you are using for ensuring that the solar heat gain coefficient is brought down as low as possible. You want the light inside, but you don't want the heat inside. you don't want the glare inside. So how do you get all these positives and keep out the negative one? Is the right selection of all those material you require, either on the walling or on the windows or on the glazing side, or the treatment that you do for facade treatment. All this will cut away the bad levels, like the good cholesterol, the bad cholesterol area. You got to find out, therefore, how to harness all that. Self-shading, what type of things you will design on the, then the building materials with the right U values required on whether it's going to be autoclaved aerated blocks or fly ash based blocks or insulation material or efficient building envelopes, high performance glass and shading devices. All this becomes an important one. Facade and shading becomes an equally important component. Then, of course, the next component is where most of the people in the sector on the MEP, mechanical, electrical, plumbing, firefighting, and other services, critical services there, all of them consume energy. What is that they can do in air conditioning? What is that they can do in lift installation? What is that they can do in lighting? So therefore, all those things will be contributed by the other specialists on that. But this particular component that Ashish will be talking today, building upon a large way, of course, I'm sure he'll touch on the other side also, are therefore dealing on the passive design aspects and not the active design component. A combination of both put together is what makes energy efficiency a big success. And you should be very happy to note that this is also an area where the NBC, National Building Code of India, has got a clear chapter number 11, part 11, called the approach to sustainability. And therefore, this aspect of energy saving and other related saving for sustainable development becomes an important thing. And NBC is the first code, again, which has brought out a separate chapter on glazing. Glazing is a very important component, just like all your other walling material. That also is an important medium. So the window to wall ratio becomes an important component. How much percentage of the whole walling is a window, or are you going to cover the wraparound like a glass case, hot case, which is required for other geographies of the world, but not Indian requirement, because you have the clear design sky, the heat and light are available. How do you design those WWR, or the window to wall ratio, and where do you put those particular windows in terms of ratio component point of view is a very important component of design. And again, do you do the glazing or the particular building using plain glass or tinted glass? Are you going to use single glazing or double glazing on and what type of U values changes can happen? I was just going through even the latest NBC provisions and various other ECBC codes, etc. You'll be very happy to note that even on the areas on U values, there can be a phenomenal amount of change happening depending upon clear glass or tinted glass, single glazing or double glazing, the frames that you take over there, wood, fiber or vinyl or metal or related one. So the selection becomes an important component of all these materials to do that. And along with that is the issues related to using high performance glass in a large way. And these days we are integrated photovoltaics which are coming in along with the windows themselves, leave alone the roof component. I'm not even touching on the roof element because facade is the main theme here. And therefore, what type of glass you can have, high performance glasses, and building orientation, so the heat gain is low, and the value of the U value and the SHGC to be brought there, and also light transmittance component to be high, light, yes, but not the heat as well as the other one. What we do on the east and west, what we do on the north and south, these are specific aspects which the architect and the civil engineer can work together in this particular area, especially the material and the type of specification, the type of thermal insulation value that we can get, etc., become an important component. Even within the envelope design component, you have to really work on the issues on even in addition to the normal fenestration, vertical fenestration also comes over there, and you also have to the use of static shading devices, very important. That was there earlier, but now latest is dynamic shading devices based on the sun path and envelope. Keep on moving, and I'm sure we'll be hearing some fantastic new options which Ashish might do in terms of the facade and all that. Our maybe 20, 30 or even 40 years back, all they did is sunshade to be done. You know, That's a small little component of addition on top of a window to have that is a shade from the sun is an important component. So beyond that is the whole facade design has become much beyond than just a sunshade, which was 30 years back, and it's a scientifically assessed aspect, and that's what is very important, and how you will be able to contribute in a big way. Can you imagine the amount of energy saving that can come just by good facade design, as well as the dynamic moving shade one, and the vertical fenestration and other related component there. It can still contribute to around 15 to 20% of the saving, leave alone the contribution from the wall and other material, etc., and the active components coming in this particular segment. The codes and standards are there. Then you have the Energy Conservation Building Code, which was brought out in 2007, and that has been revised in 2017, but you brought out the issue in 2018. There are a large number of components which are covered in the overall ECBC rating of a particular building for energy conservation point of view. How do you deal with that particular one? And that's a interesting component between architecture, building physics, and electrical engineering, and the all together. So it's an interplay area. It's not pure architecture, it's not pure building engineering, civil engineering, or electrical engineering. All the people have to put their mind together if you want to really have an energy efficient building at the end of the day. If I can say I am saving 40% of the energy that a conventional building, and this is my green building there, I should be able to show what is it that I added in this particular building to save that 40% energy. And energy efficiency is an important component where in the green building rating system, we give the importance and weightage to the extent of sometimes as low as 20% for buildings without air conditioning, but in certain buildings can give in 50%, in a data center can give even 70% on the weightage coming. So weightage on the energy efficiency component as a result of all these passive and active design together can easily come to around 30 to 35% on a median level, and very high level on some of the very energy guzzler type of buildings which require higher level of energy, which also brings into another component that the IGBC's green building ratings is not like other rating system or US rating system or other competitor where they have vanilla rating coming over there, irrespective of the energy. We have 26 rating system because each building has different levels of energy needs and also capacities of absorption and utilization, and therefore we have the rating system exclusively for the offices or schools or hospitals or residences of various category and also other area, whereas some agencies do the same amount of rating to do a commercial complex, a hotel complex, a hospital complex, a school complex. No way. That's not the way IGBC has done it. And therefore, when you say with a sense of pride that we have done around 7.61 billion square feet of green footprint as on date, which is 2020 now in September, and less than about 2 years from now, by the time we go 2022, August 15 will come, and that will be India at 75. We hope to do around of the order of around 10 billion square feet or 1,000 crore square feet of green footprint will be coming. And energy is a very, very major component there. And the utilization of renewable energy is a major component that will come, which was only of the order of around out of the total 3.78 lakh megawatt of use. That is only around 40,000 was used, but that's going to increase to as much as about 1 lakh in the next about 2 to 3 years time period, where the renewable energy component itself will be contributing to around 20%. At present, it's just around 11% coming on that. So therefore, it's an important component to be covered, and the design of the building will take care of that also into a larger, besides the solar photovoltaic that you can have or integrated photovoltaic to come, another related component. But the most important thing is what can be the structural, civil and other construction system that you have to put, which can be, as I said, static or movable, other related depending upon the solar path or whatever, are things which are now moving. There are many interesting buildings and very good architectural companies, consultants who have brought in those things, but to convert that design into a construction feature, which can also take care of this particular response system, is an important thing. I'm sure we will be able to hear from Ashish in a big way. I'm eagerly looking forward to hear his wonderful presentation. He is a very prolific speaker, very articulate, and very rich in contents. I have seen many times Ashish's presentation. I'm sure each one of you will be very happy to hear the presentation. I want to wish him all the best for the thing, and thank you, Dominic, for calling me over to share some of my thoughts on this particular important topic. Thank you.
Thank you.
Wishing
Thank you
Ashish all
so
the
much,
best.
sir. Thank you so much. Wonderful keynote address by you, sir. Thank you. First of all, I want to, I know you have a very busy schedule for the day, and in spite of your appointment at 11, so you spared your 15 minutes for us, and we are blessed to have you, sir. Thank you for wonderful opening remarks you have given, and thank you. You have a wonderful day, sir. God bless you.
Thank you. I'll take leave.
Thank you, sir. Thank you. So,
Ashish, I'm going to request for your presentation because, which I thought you should later on. I'll look at it. Thank you.
Of course.
Sir, if time permits, you can come back during question answer, maybe by 12.
I can try, but that's still 1 o'clock. That program. Let me see. I might join. I'll join. Okay, depending upon that. Okay.
Okay. Okay. Thank you, sir. Ladies and gentlemen, I now like to present the speaker of the day, Sri Ashish Rakheja, Managing Director, Managing Partner of Eon Consultants. Ashish is a partner or Eon consultant and has a postgraduate degree in thermal engineering from IIT Delhi with over 28 years of work experience. He is a seasoned consulting engineer who has designed over 3,000 projects including hotels, airports, hospitals, retail, residential, commercial, high-rises and industrial projects. Mr. Rakheja specializes in high-performance buildings and has been actively involved in leading design activities in electromechanical services for 10 net zero energy buildings and over 60 platinum-rated green projects in India. He is spearheading the green building movement in India in a capacity as a role as a chairman, technical committee of Indian Green Building Council. Mr. Rakheja is also the board member of ASHRAE USA. Mr. Rakheja has won many awards and delivered over 1,000 talks on various facets of building design across the world. He is an active member for over 20 technical society and regulatory contributes his time in writing standards and codes and positions papers for government of India, government bodies and technical society. He is also involved in imparting training to budding architects in the field of building services and the visiting faculty of leading schools in India.
Dom,
Yes.
Ashish here. I think in the interest of time, let's start. We've already
the last paragraph, Mr. Ashish Rakheja, along with his 10 dynamic sustainable experts and engineers, shared a dream of Vikal, which is an alternate approach to design by moving away from age-old practices. Their mantra of thinking out of box paved the way for creating Eon Integrated Building Design Consultant LLP. So these are the affiliations of Mr. Ashish Rakheja. So just I'll run through it. And he's one of the well-known face in when it comes to smart building, when it comes to sustainable building. Over to Mr. Ashish Rakheja. I'm sure we're going to enjoy his session. Thank you very much.
Thank you so much, Dom. I'm going to share the screen. All right, so I hope you can see it now.
Yeah, clear.
Okay. Thank
Go
you.
ahead. Thank you.
So, namaskar everyone, and very good morning to all of you. Thank you, Dom, for very generous words of introduction. It was quite humbling. And thank you for getting Suresh Saab here to do the opening remarks. It's always a pleasure listening to him. He's a man full of energy. He's been guiding now the green building movement of India and has done a commendable job. In fact, he's a person that you can speak to him early in the morning, late in the night, and he's got the same energy to display. So we are blessed in our country to have another Doyen leading the green building movement, and we have a bright future ahead. The topic that I have today is on facades, and when I was talking to you, Dawn, you had this suggestion that I must speak on this forum sometime, and my passion has always been net zero energy buildings. And then you said that you like to have something which is going to be different, and it got me thinking. Then I thought that, look, one of the biggest challenges that I've been facing is on the facades, and the learning that I've had is how to link the facade to energy, to health and well-being, and the general design aspect. You know, there's a very interesting example I came across the other day, where the whole focus was on aesthetics, which is fine, which is nothing wrong with it, but in the process, not realizing the penalty which the building had to pay in terms of energy and in terms of health and well-being of the people. So it came to a basic question, a debate on the other day on the project, where is the tail wagging the dog, is the dog wagging the tail? So of course, the buildings are meant for people. It is for their wellness. It is for their well-being. So it's important that any designs which are done do take that into account, and that's how this topic came up. Incidentally, I had spoken on this topic about 10 years back, and I was reminded, I was just going through my notes when I was preparing the presentation, and I came across the old presentation. I'm going to talk a little bit more on it going forward. You know, what happened was I pulled out those notes and I started comparing. I said, my God, is this what we spoke about years back? And look at it today. Yes, we have moved a lot in terms of our learning, but then we have still not moved enough. The very fact that we are doing these basic conversations still, the basic conversation still seems that there is a gap somewhere out there. So let's go through the thing. What I've done is, in this presentation, I've brought in some of the old slides from my earlier presentation, and also try to mix them with something what is happening today in the country to see where we stand. If you look at the facade, it comes from a French word, and which means the frontage or the facade. We always talk about it in context of building, that facade is like a skin on the human body. And of course, what you see is the appearance of the skin, which matters a lot. Facade definitely defines the way the building looks. In fact, our first interaction with the building is by looking at the facade of the building, and that speaks volume about what the building is like or is going to be like. We have seen with the green building movement over years, and many of my fraternity members from the green building industry and from the air conditioning industry would agree that facade has an important impact on the building capital cost as well as the operation cost. And a lot, when we are designing in terms of our air conditioning system, depends on what kind of facades we encounter. But what is also very important is that facade has an impact on the health and well-being of the people. And which is proven medically, be it hospitals, be it a hotel where we go to, or be it an office building, a day-lit building makes a lot of sense. In this age of pandemic, what it has taught us is to go back to basics. And one of the basics is that the sun energy is the best in terms of giving us a healthy environment. And that's where one of the important areas of the facade comes into the picture. As I said earlier, I'm going to pull out some of the slides from my old presentation, and I've attached it here. This is what I had done about 10 years back, where I took a building of about 300 odd thousand square feet. And those were the days we used to do 150 square feet per ton, which I believe many of us have moved away from it. But still, in some part of country, I do come across these designs still. When we are analyzing this building, we realized that nearly 50% of the heat gain was being contributed by the envelope itself. It had good window wall ratio. It had a good amount of glazing on the facade. 25% of the loads came from the internal, and 25 came from the ventilation, the fresh air load. Out of the envelope load which were there, 90% of them came from the four sides because a high amount of glazing was being used. 10% came from the roof. And when we looked at further in terms of the four walls or the four sides or the facade, we found that 90% of the heat gain was from the glazing and 10% was happening from the walls itself. So the glazing did play an important role in the overall context of the facade of the building. Those were the days when we used to play with the building using the simulation tools. The simulation tools had just come out, and I also decided to play with the same building and see the relevance, how relevant is the whole thing even today. I took that building and simulated it all the four climatic zones, the major climatic zones of India, which is composite, hot and dry, warm and humid, and moderate. And interestingly, if you look at it, the internal load remained constant because there is no change in the internal load. What did vary was the fresh air load. That means the amount of fresh air which was being injected. Obviously, in case of composite climate, it has a higher impact as compared to the other climates. And the envelope load also varied in this context, as long as the envelope was not optimized. I'll speak more on this, go further. Then I decided to further play with the whole thing and said, let's optimize that how far we can drive this building. This was an imaginary building, so I could rotate it around. I could do anything with that. So we started rotating the building every 45 degrees. And you can see here the energy consumption dropped, and at a particular orientation, which was the north-south orientation, which is what Mr. Suresh Saab also spoke about, the building had the least energy consumption. So I picked it up. To the same building, we started looking at the window wall ratio. The building that I had started with had a window wall ratio of 55%, which means the 55% of the facade was glazing. It wasn't 100%, it wasn't that bad. It was a good building to have 55% area as the glazing. Started playing with it, bringing it down to 20%. And at 20%, it did yield a good result in terms of giving us the lowest energy consumption out of the optimized lot. One would argue that at 20%, your daylighting might get affected, but there are many such good examples you would find around. What we have seen in my own buildings that I've worked in, we have designed, we have found that 20 to 25% of the glazing area is also, if it is done rightly, is able to 100% daylight the building. And this is the finding was there in this building also, where the 22% actually the glazing area gave us 100% daylight building. And these are some of the examples of the green buildings which have come up in India, where they use the window wall ratio in a very beautiful manner. Then we started looking at the shading devices. Since this was an imaginary building, I could play with it. We started doing the shading devices, which is the chhajjas, and extended the chhajjas from a 0 to half a foot, 1 foot, 1.5 feet, 2 feet. And obviously the bigger chhajja gave us a good saving in terms of the direct sun could not come inside, and we could have a better shading on the glass itself. We took that, went further and looked at some of the examples worldwide where the shadings have been deployed beautifully and very appealing, aesthetically appealingly by the architects in the world. We started looking at the glass selection. Obviously, there are good glazings available today. And if you look at the number of companies, the variety of glazings, there are excellent selections available out there. In fact, the other day I came across a beautiful glass from a company which was practically clear. It was an architect's delight. Uh, and simultaneously it was also giving a good protection against the a good U value, and the shading coefficient was something that was also decent enough. So when we looked at that, so these are kind of glazings which are available. We selected a good glazing and applied it here. Then finally looked at the wall assembly. In those days, we had still not started thinking about insulated walls. But today, if you look at the ECBC, the requirement of the insulation in the walls is very much out there. We used a wall with an insulation, and finally at the end of the day, and you would be surprised, even in the commercial applications, the same has been done. If you look at one of the largest malls in the NCR, Delhi NCR, which is Mall of India, has actually got an extruded polystyrene insulation on the outside. So there are developers, there are projects where these insulation materials have been used, despite their talks about being expensive or cost being an issue. Just these 5 steps of optimizing the building envelope brought us down. The air conditioning load was brought down from a 2,000 ton to half, to about 1,000 tons. The energy consumption came down by nearly 35%, and there was an equivalent saving in the carbon emissions also. That was very interesting in that time, because this was my start of understanding the facades and my start of interacting with the facade designers, with the architects, in terms of designing the high performance building. We took this building again and looked at it from, now said that how we can further optimize it. I Googled at that point of time and came across the world's best glazing. And when we applied this world's best glazing to this optimized building, which was very simple in terms of right window wall ratios, right shading devices, right insulation, right glass. And when we applied this world's best glass to this building, we could get only 2% more savings on the energy, which proved that it is not important for us to put the most expensive glass, but it is important for us to put the right way and the right kind of glass. We started looking at more ways in which we could save energy. We looked at the thermal break in the window frames. This ensures that there is no climatic contact between outside and the inside. The thermal breaks are excellent, but even till date, we don't use them on our projects, in most of the projects, because of the cost issues. Incidentally, the thermal break did yield for this building nearly 5% saving in the energy. And it does make sense to look at the savings coming out of the thermal break. Started looking at more innovative solution. We said, why don't we look at putting a green wall? Because that green wall can actually shade the facade and help us. So that incidentally gave us another 3% saving on the energy front. And these are some of the examples worldwide where the green walls have been very successfully used on the building facades. We looked at the double facades, where there are 2 layers of glazing with a gap in between, and that gap is basically acting as an insulation layer. In case of colder climate, it acts as a heat trap, and in case of warmer climate, it is actually ventilated, and as a result of which the heat from the outer side being transmitted to the inner side gets reduced. So the double facades, the ventilated facades, did give us a saving of 5%. So what it did prove to us, and these are some of the examples worldwide where the double glazing have been tried out, the ventilated facades have been tried out. I've again not seen the examples of it in India, not many of them, but it's something that is there. So the important thing was that the most optimized building that we had uh, doing those basic 5 steps which I spoke initially and applying to it now the things like the world's best glazing or a ventilated facade or the green walls or thermal break could give us limited savings, and the fundamentals of the design were the key. Now this is what we worked on and talked about 10 years back. Since then, the world has moved a lot. The country has moved a lot. Dr. Suresh Saab spoke about the National Building Code, Chapter 11, and in Chapter 11, which is on sustainability, we have covered the passive design aspect or the facades in big detail. There's also the ECBC and the ECBC-R, which are come out. R is for the residential buildings. Both of them, again, there is a big focus on the building envelope and the role that it plays in terms of the energy. And so far, all the talks have been around energy. Our discussions have all been around energy itself because that's been the driving issue till date. We had a great green building movement. Suresh Saab again mentioned about 7.5 billion square feet of the green footprint that we have. And this green building movement, even though I have been part of it now for 2 decades, I felt that it missed the important connect, which is the common man. The green buildings, till date, they connect very well with the designers, with the architects, with the owner, maybe with the people who are associated in construction with it. But when it comes to the people inside, their appreciation of the green stops because they are not directly gaining out of it, or they don't see any gain out of it. And that's why the newer rating system, which is now out in the market, which is the WELL or the Health and Wellbeing Rating System, which IGBC came out with in 2017. And similarly, the US Green Building Council has been promoting the WELL certification. If you look at both of them, again, their focus is all about people. And it directly impacts the people who are working or living or staying inside the building. Their certification way, the levels are exactly similar to what the green buildings are all about in terms of being silver, certified, gold, and platinum. But their focus is, again, as I said, is on the wellness of the people. If you look at the IGBC rating system, issues like indoor air quality, issues like comfort, and the comfort includes visual comfort, which is facade, thermal comfort, facade, daylight comfort, facade, sound, acoustic comfort, facade, and the indoor air quality to some extent dependent on the facade, which is what I'm going to show to you. Everything, a large number of those credits are related around the facade of the building. If you go to the WELL certification, again, air is facade, light is facade, thermal comfort is facade, sound is all facade. And some of it comes down to the intellectual well-being, emotional well-being, all gets linked to the kind of environment we are providing to the people inside. So what I'm trying to say is that the shift is perceptible. Shift is about the people, for the people, that what we like buildings to be. I'm going to take you some of the examples of the buildings. And since the time is, I like to respect the time, even though Dominic has been kind enough to give me 45 minutes, but since we started late, I'll try to go a little faster. I'm going to show you, this is a building that we are doing in Mumbai, and it's practically all 4 sides glass, and a lot of buildings in Mumbai you will see like that. Despite having glass on all the 4 sides, this was the architect had decided to use a very dark glass. And if you look at the daylighting level inside, which is, the building is about 60%, the floor plate is about 60% daylit, having a 40% VLT, which is a visual light transmittance, that is a fairly dark glass. When we came in, we said, let's look at a lighter glass. When we went to a 50% VLT, you could see the daylighting levels increased. Went to a 60% visual light transmittance, the daylighting levels increased. Went to 70% daylight transmittance, again the daylighting levels were But more important is then the daylighting is also the glare which was bringing in. We could see that a 60% VLT glass could serve us a good purpose as far as the daylighting is concerned, as far as the wellness of the people is concerned. But look at the glare. And if you see the videos which are running on the screen, I'm sure you're able to see them. You would notice that there is a good amount of this gray patch that you see indicates the extent to which the light is penetrating inside on the floor. On both the south and the west side, there is a deep penetration which is taking place. On the south side, practically entire year, there is about 9 hours of the day, the penetration of sunlight is onto the floor, nearly for 9 hours in a day. One could mitigate that using simple steps. Similarly, on the west side, the penetration was nearly 5 hours every day for throughout the year. So ultimately, it meant that both along the south side and along the west side, one cannot even have the seating. And if somebody is sitting there in our need to occupy the floor plate completely, what it will imply is that those people will insist on the blinds being pulled down. The air conditioning engineer will never be able to satisfy them in terms of thermal comfort, and is going to be a total discomfort for those occupants there. Once we did those corrections of the building, again, I'm not getting into the correction because the intent of this presentation is not about how we correct a facade, but intent is how the health and well-being of a person, of the occupants, is related to the facade, looking at simultaneously at the energy aspects also. When we corrected the facade design using shading devices, right kind of glass, we could come to 97% of the floor plate daylit and no glare. No glare, absolutely, you can see on the floor plate. And when we went towards the energy side for the same building, if we had not done anything, if we had stuck to the old building design, which it was there, the earlier building would have consumed 5% more than the baseline of the ASHRAE 90.1, which was defined. Mind it, the green rating is given to you on how efficient you are over the baseline. And in this case, we are consuming more than the baseline. So it's in a reverse direction. And here it is, this building had an air conditioning load of nearly 1900 tons, 5% more energy compared to what the ASHRAE base case was all about. And look at the elements of the facade, what they could do by correcting the facade design, making sure there's the right glass, making sure there's the right insulation, making sure there's a right shading, making sure there's the right window wall ratios. One could get the load down to 1100 tons just by the right kind of facade, right kind of selection of the facade. 800 tons of reduction. And look at the energy savings. Nearly 18% energies is now being saved over the ASHRAE base case. Then, of course, we looked at the electromechanical aspects also, and we brought it down ultimately to 1000 tons, from a 1900 ton down to 1000 tons, which was a big journey to travel in this case. It's another building, and incidentally, in this building, the brief from the tenant to the developer was that they are looking at an envelope load of less than 1 watt per square foot, which it implies is that the heat gain from the building envelope, the brief is that it should not exceed more than 1 watt per square foot. And to give you a context, in a conventional building, it could be as high as 3 to 4 watt per square foot. So coming down to 25% of what a conventional building might do. Another brief said 80% occupied areas daylit. Another line said the zero glare in the indoor spaces. And another line said 100% spaces with outdoor views. Now look at the brief which came from the tenant. It was a build to suit building to the developer. And the developer has to comply and has to demonstrate. Now who's going to demonstrate that at the end of the day? And it becomes the role of the architect, the HVAC engineer, the energy engineer, all of them to work towards to get that. Now look at it. We started with this. This was 60% VLT glass. Again, I'm just showing a glimpse of it, where we went and how it went. 60% VLT glass. We were nearly about 80% daylit all over the place. We were perfect. It had a good amount of glazing on the facade, and we could get ample daylight in. But the problem was the glare. Whereas the first two buildings the glare was within control to some extent, the third building had all the west sun coming in with a very bright glare patch being there. And nobody again could sit along with that, along the glass here. Simple thing, what we could tell them was cheap and best. Shift your core from what you had on the east side, take it to the west side, block the west side using the core. And that simple thing could cut down the glare by less than 50%. It was a great suggestion. Everybody from an engineering fraternity, everybody loved it. But from an architectural and the aesthetic front, it did not make sense, because this facade overlooked into a beautiful green area, and the whole pleasure of looking out was being affected with it. So we came out with a different strategy. In fact, today there are more opportunities available to the architects and to the facade designer to look at technology option. So there's something called parametric design. Here, the shading devices were put outside using this parametric system. There are about 2,000 iterations being done here on the screen. You might see the video running of the shading device using this software, which gives you a very beautiful integration of the three main elements, which is the energy, daylight, and the glare. And once it was done, this is the kind of design which came out of the shading device. It was applied to the building, and you can see here, to a large extent, the glare was also cut down on the facade. And we ultimately had about 83% daylit areas on the floor plate and glare being less. So moving further from here, I think this part of the thing is clear to us about the role which the facade plays on the energy. And one could select a right kind of thermal conduct. Okay, on this project only, in fact, we could select what should the wall U value be. We played with the options of increasing insulation thickness on the wall, and how does the energy consumption come down with that. Similarly, on the roof, increasing insulation thickness on the roof, and how does the energy coming down with that, and where is the best inflection point where you should be selecting your insulation thicknesses. Similarly for the U value of the glass, similarly for the shading coefficient of the glass. And then drawing options, there were 10 options of the facades that were drawn, out of which 3 could meet our requirement of bringing the heat gain from the envelope less than 1 watt per square foot, which is what the requirement was. Now, the similar things have also been done for the hospitals, where it's been proven, and this is a project in Delhi, where it has been proven that in case of healthcare, the relationship between the daylight and the patient healing has been linked, and you can have articles after articles on this. You'll find it on the website and the doctors talking about it. Simple thing on this project, it had a good glazing ratio, good glazing on the facade, amount of glazing on the facade, but it was all on the north side. And look at it, just by doing the glazing design right, we started with a 280 square feet per ton on the air conditioning front, and we ended with 400 square feet per ton just by getting the facade design right in this case. Moving further, this is a hotel which we are working on in Delhi, and similar here we did examples of double facades which were tried out. We could achieve about 98% areas being daylit, and look at it again, starting with air conditioning load which was running at 230 square feet per ton, going to as high as about 530 square feet per ton, and facade playing the major role. And again, the most important thing was giving comfort to the people inside, because whenever you go to a hotel, our first instinct is that we like to have a seat next to the glass, sit there, because we like to have to look outside while we are having our food or having the meeting. And in case you got a direct sun coming in, there's a discomfort out there, the whole purpose of the glazing can get lost. And then going further, you can look at it now, how beautifully the architects have started trying out this integration of facade, shading devices, uh, right kind of glazing, and the window wall ratios. And this is a small project in Noida that we just finished. It's got a platinum rating, and there is a screen which has been put. It's actually, there's the whole thing is a screen around it. Moving further, I think the important aspect is we are also going towards the net zero energy buildings, where again the facades play an important role. This is a project that we are working on in the eastern part of the country, and the challenge in this one is the footprint of the building is very small. It's just a 800 square meter piece of land, and the building is going 45-meter tall. Now that's a tall building with a very little area available on the roof for putting the solar panels. The client brief is clear. They would like to have a net zero energy building, and they wanted to wrap the building around with the solar panels itself. Now that's easier said than done, because moment you wrap the building with the solar panels, there's a loss of view, there's a loss of daylight, and there's also the whole aesthetics issue which comes into the picture. So first we looked at the shadow which is being casted by the building on the floor, on the ground. And this is the green trapezoid area where there's no shadow casted whatsoever. So in this area, there was a car park which was put, and on top of the car park, there are actually solar panels. The intent is to get as much area for solar panels as possible. Then the facades are being studied. So these are all the four sides. One is looking at it on the y-axis, you see the time of the day. On the x-axis, you see the month. So one is studying that what is the kind of solar radiation which is coming on the roof or on the four sides, and what is the solar intensity, radiation intensity we are talking about. This is solar exposure. These are good tools, softwares available for us to analyze the building facades more closely. And here one can see the hours in the day every month that the solar exposure is available to us. Once we know the solar exposure hours, once we know the intensity, we can find out what the generation is like. The next part was wrapping around the building with the solar panels. And there, you can see the inclined solar panels which are being done, so that one is not compromising on the views and the daylight. And that's what is the improvement being done on the screen. On the west side also, there are solar panels. You can see these sawtooths where my cursor is, and also on the above here, the sawtooths, the way the solar panels have been put. Once it was all done, you can see it's 99% daylit, no compromise on the daylight, no glare, and these are the solar panels on the facades which have been installed there. There were a lot of iterations which have been done to get that right. So that is high performance. You get a good performance out of solar panels. You are able to make it aesthetically appealing, no compromise on daylight, no compromise on glare, and the multiple options were studied of the solar panel angles on the facade. Finally, what came out is that the building could generate about 228 megawatt hours round the year, which amounted to about 67 units of electricity per square meter per year, which is the EPI, is what we could generate out from the solar panels wrapped around the building. The engineering was done reverse, where the whole air conditioning systems, the electrical systems, the electromechanical was designed in a way that we do not exceed what we are able to generate from the building. And you can see here the step by step, the consumption was brought down till the point the consumption and the generation matched to achieve what we call a net zero energy building performance. And you can see the examples of it, how the solar panels are wrapped around the building. And these are the inclined solar panels, which I mentioned earlier. The application of it goes on even in a retail. What you see here, there's a retail project, and where there's a big skylight on the roof which has been provided, which is what we see in a lot of retail applications. But the architect and the client did not realize what that skylight was doing to the building. And in terms, you can see here the amount of sun that started coming inside the building, and that sun was not only bringing heat, but it was making the indoors uncomfortable for the people to stand there, and it was also having an impact on the displays of the shops, because when you had a brightly lit sun which was falling directly on the display area, the display of the shops, it was not allowing that effect to come out. So the improvement of it in terms of trying out reducing the skylight sizes, one was done. That did not work. It did not really yield the thing. And there are lots of options. Again, as I said, the intent again is not to get into a design aspect, but to show you the relationships which are there. There are three options which were tried out. One was the ceramic fritting, and this is the kind of fritting which was done on the facade, on the skylight. And today these examples are also used for the facades also. For our glazings also, we have been doing that. Digital printing, which is what this looks like. It was tried out. All of them option worked very well. And another one which the client was looking at was a sun controlled glass, where based on the intensity of the sun, the glass changed its color. And what you can see here, this is courtesy Saint Gobain. I've got this pictures from them, and you can see here how the sun, moment there's a bright sun coming in, the glazing changes its color. It starts becoming darker and reducing the intensity of light and the heat gain which is taking place. So these were the things which are tried out, and it worked well. Now that's on one side of it. I want to bring it out to another side element altogether, biomimicry. And this is again a slide which I'd used 10 years back. I said that biomimicry is something which makes a lot of sense. And why can't you have a facade which opens up and closes depending on how your ambient is like? 10 years back, I felt I was ahead of time. We could talk about such a thing. There were these examples I found on the net at that point. There's a building in Chicago where such a thing has been attempted there. And today we are working on a project like this, where exactly the same concept is being discussed about opening and closing of the facade. What you see here is a big hall, and on top of the hall, there are these 6 arches which are there, and it's series of arches with the glass here in this area. This glass is bringing the daylight, and the intent of the client here is that the entire hall underneath it, they would like to have it naturally done. No mechanical air conditioning should be there at all. And for that, it is important this opens and closes, the facades open and closes depending on what kind of ambient temperatures and the wind velocities are there outside. Now, this is a building which is coming in the colder part of the climate. And if you look at the psychrometric, most of the hours of the day are on the left side. My air conditioning fraternity friends would know. We are dealing with a colder climate situation here. And that's why we don't want any mechanical cooling or mechanical heating there. We'd like to have a system which is natural. And these are the wind movements which are being studied. And we tried out a couple of options that if 60% of the glazing can be opened, 80% can be opened, or 100% can be opened, how will it work? And there were CFD models, there were CFD companies were deployed, and this is a CFD model they came out with. Suppose I have a 60% opening of the glazing, of the top glazing, which is what I'm showing here. What happens here? What is the kind of ingress of the wind which takes place inside? What happens with the 80%? What happens with the 100%? How does it work? Those models were tried out. And then strategically, again, I'm not getting into detail of it, strategically the cross ventilation mechanism has been worked out there, getting the right amount of glazing opening, and is all automated. So the glazing opens and closes based on the inside temperature, based on the wind velocities outside so that it's protected from high velocity winds, and look at the wind flows which are taking place inside the space itself. And just to show you a final image and what it would be ultimately, this is a cross section and how the wind is entering inside the space, and it flows through the area. And then thereafter, these HVLS fans have been installed inside to enhance the air movement to get this kind of a performance inside the closed space and make the whole place comfortable round the year, except for few hours, which is on the very hot side or the very cold side. And 90% of the time, it will be able to work without requiring any air conditioning at all. So it was interesting to see that what I spoke years back is something that we have the opportunity to work on and is being tried out now. Last area thing that I want to talk about is about the indoor air quality and what is the impact which the facade has on that. This is a hotel that we are working on. And in this hotel, the client's brief was they wanted to have the best indoor air quality. Very easy. One can go ahead and put the great filters. One can go and put most expensive filters, and my job is done. It's as simple as that. But what we found out here was, again, the facade had a very important role to play here. In this building, what was happening was, in this hotel, what was happening was, with the wind pressures outside, because the wind is blowing outside, and the facade always leaks. There is no such thing as an airtight facade. And we are talking of PM 2.5 particles, because when we talk of PM 2.5 inside, and PM 2.5 is a very, very fine particle. It can move in through very small openings of the facade also. With the wind speed, the positive pressure that was there inside the room, it was not able to take care of it, and there was an ingress of the outdoor air pollutant which was taking place. So what was done was that the pressure relationships inside was studied, a right amount of pressure by ensuring that we are supplying X air and taking back only about 0.6, 0.7 X air, leaving 20 to 30% air behind, so that the room is always under positive pressure and the outside air high pressures are not able to overcome, and we are able to get a good indoor air quality. Going forward, we see the facades. Now, let me take you to the last part of my presentation, which is the future. And going forward, we see the facades becoming more and more interesting, more challenging. Aesthetics and the performance is going to get linked. These are the building integrated photovoltaics, which we've already started seeing coming in some of the buildings here. There are talks about the wind energy also being harnessed and being made part of the building design, and we'll see that too. These are some of the examples on which we have seen the phase changing materials used on the facade, where in the daytime they absorb the heat, they do not let that heat get transmit inside the building, and in the night time they reject the heat. These materials reject the heat, and there is no heat which has gone really inside the conditioned space. And some of these, there's also a very interesting building that I came across where they had used algae on the facade. In the summertime, the facade is all clear, and in the winter time, when there's not much of a sun, the algae starts growing and it starts shading. It's the other way around. In the winter, the sun is very clear, the facade is clear. In the summer side, the time the algae starts growing and it starts shading the facade so that there's a direct sun not going inside. And then the algae can be burned to generate the energy also. There's also the science of hydroponics which is coming in, where the facades of the building are being looked at for addressing the food crisis and growing the fruits and vegetables on the facade itself. So these are some of the exciting things which we are going to see in near future, and that's coming up. I just want to end the presentation by showing you an example of my own office where we stay in and what we have gained out of being part of a healthy environment and a green environment. This is my own office where I'm sitting right now and talking to you. Incidentally, for last 1.5 hours, there's no electricity. We do have generator, but I'm not running the generator because I'm the only one sitting in the office. I don't have a fan, and it's pretty comfortable inside because there is no direct sun. It's nice. Maybe it's about 27, 28 degrees here, and I just got a ceiling fan which is running. The floor is 100% daylit, 100%. Not even one area of the floor doesn't receive daylight. And look at the amount of daylight which comes, no glare whatsoever. The office has got a IGBC platinum rating or green scale, and has also got a platinum rating on a health and well-being scale. And these are some of the images that you see here. The way the planning has been done, again, you can see that we have kept the workstations away from the direct sun, so that people are not getting a direct glare or direct sun here. And that's the view from the conference room. We maintain a temperature of 27 degrees inside the space with the fans. So you see these are examples of the HVLS fans you normally see at the airports and all. We are using it in our building. These are images from our own building. We got an air purification unit. We got a fresh air unit. We are dumping the fresh air inside. And that's the PM 2.5 levels which are maintained inside the building at 14, whereas the Delhi ambient PM 2.5 levels are 500. All 5-star air conditioners. And this is the image of the office. You can see how the fans and the air conditioners have been put in the ceiling, insulation on the ceiling, and we are running. Even the lighting is planned in a way that it falls only on the workstation with a little spillage outside. So all the surrounding areas get an indirect light, and only the direct light is on the workstation. And these are some of the images of the office itself and how the people inside enjoy the office space. Water efficiency, these are some of the building materials that we reused. And there is also something called radiation management. I'm not getting into details of that. So we have a small healthcare facility, and these are the library areas, and these are the huddle spaces. And the office featured recently in ASHRAE High Performance Building magazine, where it was done as an affordably green office, and where it was all about, the image of green is all about rich corporates, big buildings, big clients. They are go for green. But in this case, we wanted to prove that it's not about big, it's about right design, right facade, right design. You can actually get an affordable green office also. So that's the end of my presentation, and I feel that if we have to keep driving down the performance of the buildings in terms of energy consumption, in terms of minimizing the air conditioning systems, we have to move towards facades, look at the facades more intently, and the relationship what they play with respect to the human wellness and respect to energy, respect to the overall performance of the building is big. And that's why one of the fastest evolving elements today in the building design is facade. So thank you very much. I'll end here because we've taken exactly 45 minutes, which is what I promised Tom I'll do. Thank you so much. I'll be open to questions if there are any, and happy to take them.
Thank you, Ashish. Wonderful. I would say you have given a lot of insight on facade design and the choice of the building material. And I could see our NBC chair on electrical, Mr. Bhavani Prasad, has commented that I've been enjoying your presentation with a new update look, and in particular the transformation over past 10 to 15 years. That's a compliment from Mr. Bhavani Prasad. Wonderful. I think nobody's raised any questions so far, which means it has crystal clear in your presentation and very informative. And I'm just waiting to see. There are 3 questions. Ravi, I think you're supposed to handle the question answer. There are 3 questions. Can you take it forward and post that to Ashish? Ravi, are you there? Ravi? Okay. Ishwaraya, complimenting again, excellent presentation, Ashish. Are there tools to evaluate the acoustic performance? Is MSS, that is maintainability scoring system, using ANN, artificial neural network? So he's asking, is there any tool evaluate acoustic performance, Ashish?
Let me just read this. Well, that's really beyond my area of expertise. Ishwar, I think you were put in a bouncer to me, so I'll accept that bouncer. I'm sure. Acoustics is not the area where I work in, but I do know that I was yesterday only attending a presentation by an ASHRAE expert. We did talk about the acoustical performance and how to evaluate that. So there are tools which are available. Uh, I may not be able to elaborate on them, but if you go around looking for them, they are very much there. So we did talk about the methods and the ways in which you could evaluate that. Sorry, I won't be able to give you more insight into that, Ishwar.
Okay. Ravi, are you there, Ravi?
Yes, I am there, but can you hear me?
Yeah, wonderful. I can hear you very clear now. I think before you come on to taking the next question, there is Umesh was commenting. He's saying 45 minutes too short. Such a wonderful presentation. They would have loved to hear you more. So, but he says too short. Oh, take it forward, Ravi. From Anil Yadav was put the question.
Okay, no, Dominic, I don't have the questions here on my screen. That's the problem.
Yeah, no problem. I'll take. Ashish, the question from Anil Yadav. Sir, why is not possible to have a leak-proof facade?
Well, if you look at this is a question I also asked, by the way, when I was working on this indoor air quality thing. So when you have windows and whenever you have windows, whenever you have the glazing which is there, there is a permissible leakage factor which is given there. So every glazing design has a permissible leakage factor because you are using hinges, you are using joints which are there. Even though that leakage factor is very, very small, but that permissible leakage factor is very much part of it. And our finding was that when you have a high pressure wind from outside and we did not have adequate positive pressure inside the space, the small PM2.5 particle, mind it, the PM2.5, you're talking of a 1/40th of a human hair size. That particle could come in inside. And that is where the focus was.
So Umesh is asking why, sir, what about the electrical consumption even in good facade design? I mean to say during night time.
I am not clear about the question, Dom.
I'll just read out as it is given. Sir, what about the electrical consumption even in good facade design also when companies are working 24/7? I mean during night time. This is a question.
So yes, when you have a round-the-clock operation, you do take that also into account. But really speaking, the daylight is only coming to us in the daytime, and in the evening hours, the major concern is about the people, the ability of the people to look inside, the ability of people from inside to look outside. So those are major concerns which are there when you're looking at the facade. But for us, as far as the performance is concerned, the major factor is when the daylight is there, even when it's twilight, how much of daylight can we get in? How much are we able to minimize the use of the artificial light? Now, as I was saying, I showed you the example of my own office. We practically start our day at 9 in the morning until 6. We do not need even a single artificial light there because the glazing is able to capture and bring the daylight to us inside in that space. Only when we are working till later in the night till 7, 7:38, we have a little bit of artificial light which is burning at that point of time.
All right, thank you, Ashish. There is a question from Sundar Paul. Surinder Paul. These ventilators are not provided. Will this help in energy saving?
What ventilators?
I don't know what ventilator is talking about. He just put this question like these ventilators are not provided. Maybe if ventilators are not provided, will it help in energy saving? That could be his question.
I am not very clear what Mr. Surendra
Yeah.
is trying to say. Maybe he
So
can contact me separately and I give you an answer to that.
yeah, we'll park that question for some time. Mm, read this. Surendra Paul said, read these days. Ravi, what do you? You have a question?
Yeah, Ashish, very basic question. Is it more economical to have glass facades instead of concrete structures or uh, facades?
Look, I never said the glass is bad or concrete is good. I don't think that's the intent. Uh,
Oh
it's
no, no,
about how we
no,
handle
it's my
the.
question. It's my question. That's all. I'm
Okay,
not saying you said. Yeah, yeah.
so it's a question of how you handle them. And there's
Okay,
nothing wrong with glass. There's nothing wrong with any of the materials. They're all materials, and it's the innovation of the architect and designers that how they handle the whole thing. So I've had buildings where they're 100% glass, and they still turned out to be very well in terms of the performance. So it's the way we handle the whole thing.
no, my question was: is glass economical when compared to uh, the other materials, other
Okay, sorry,
products?
I didn't get that question earlier. So, uh, Ravi, the bigger thing is the speed of construction because you have to
Okay,
look at it from that perspective. It's much easier to do the construction using the glazing materials.
okay,
Then there is also about the tall buildings, trying to do concreting, trying to do solid brickworks at those heights, how to handle them, how to paint them. So those are bigger challenges which are there. So it's not only about the capital cost, but it is also about the speed at which you want to finish the job and also the practical aspects of it that come into the picture, where the glass facades do have an edge over the conventional way of doing the things.
okay. It's this pace at which a project can be completed.
That's correct. Because for a developer or a building owner, that's also an important consideration.
Very true. Very true. I've
Okay.
also watched a few videos where they're talking about these translucent bricks or, these bricks, I think, which are being used today for light to enter a building and all that. Is this really true? And have you uh, come across such products?
Well, there are something called a glass bricks which have been around for a long time. And again, we have seen some of the architects and the designers using them very successfully. The variants of those products are definitely coming in. And as I said, the facades is one of the fastest evolving today in terms of the materials, in terms of their performance. There's a lot of options which have started coming in there.
Good.
Okay.
Ravi, Ishwaraya has come back with a little more clarity in his question, previous question. He's asking, I'll read out very slowly, repeating the question, MSS, maintainability scoring system using ANN, artificial neural network, technique deployed to enhance its performance with minimum LLC, life cycle cost.
Really speaking, Ishwar continues to throw bouncers at me. And
Ishwar is a what do you call? Is a too techie and
I
somehow
know, I'm
very
aware of it.
difficult.
So maybe Ishwar, we can connect later, and you can explain to me what exactly you're looking at. Maybe I'll be able to answer that.
So Anil has also have a question: do we consider glare outside, glare caused outside the building, especially from west side of facade?
Well, you should consider that today in places like Mumbai and all, when you're doing tall buildings, and when you go to the environmental authorities for getting your building cleared, they do ask a question that what is the discomfort they're going to cause to the neighbors in terms of the reflection and in terms of depriving them of the sunlight by doing that such a thing. So yes, it's a consideration that needs to be taken.
He's also asking how do we handle cleaning of double facade in dusty area, double facade in dusty area.
Excellent. I think your point is right. That's one of the reasons why the double facades have not really made a big entry into India, because of our dusty environment and the need to clean it. In fact, there was one of the projects that we are working on where we wanted to do a double facade from a sustainability perspective, but then finally it got shot down because of the maintainability aspects of it, and also cleaning, more than that, cleaning aspect of it. So yes, it's a big challenge. There are ways and means, of course, sprinkler systems and all can be done, but then it does come with a cost and a maintenance regime that needs to build up.
Ashish, we are on dot 12:30. Over to Ravi for concluding remarks. Ravi, over to you.
Hello, hello.
Come on.
Can you hear me? Hello.
Yes, we can hear you, Ravi.
Wonderful, wonderful. Thank you, Ashish. Thank you very much for this a lovely presentation. Like somebody pointed out, I think this 45-minute is really not enough for a topic like this. I'm sure you will also agree. You had to, speed up your pace in certain areas. But it certainly was very interesting, especially when you spoke about how net zero buildings are achieved today, and so much of development and advancement in the different types of facades, and foliage on facades, and so on and so forth. Very, very interesting. Though I'm not from this area of business, but it certainly was very, very interesting for me. Thank you very much, Dominic. Thank you very much, Ashish, for your presentation. I'm sure the participants can probably write to you or to Dominic with further questions that they may have. Thank you very much, Ashish, for your presentation.
Thank you, Ravi, and thank you, Dom. Take care, guys. Dom, you're talking to yourself. You're mute.
Yeah, most of the participants again from our fire and security and automation field. There are few on the construction and architect, but thank you for sparing this wonderful time and very enlightening. I'm sure you will come back to us in the future, and wish you all the best, Ashish, and thank you very much for joining our 15th knowledge series. And our next topic will be on part 4 NBC, just handling the Q&A, question and answer from the architect's perspective. So will be next Saturday would be on NBC. So I look forward to see you all again. Wonderful to have you here. Thank you. And recording will be available if you have any more information that you want to share. So please email me, and I look forward to see you next week. Thank you very much. Thank you, Ravi. Thank you, Ashish. Good day to you. Thank you.
Thank you.